It's going to be by Aleks Seovic. Aleks Seovic is an independent consultant, but also does quite a bit of work with Oracle itself on the engineering side of Coherence. And he's going to talk to you today about evolving data, so effectively allowing your data to be modified in a running cluster without restarting. And without further ado, I'll let
all right, thank you. All right, so first things first, I mean, why do we even need evolution, right? I mean, especially when you look at NoSQL movement these days, they all talk about schemaless database. And to a certain extent, Coherence was always schemaless, right? You don't define schema up front. But the thing is, there is no such thing as schemaless database. Your applications depend on a schema, whether the schema is explicit or implicit, right? So as soon as you start defining your classes in the example of Coherence, your applications, your clients depend on those classes, and you need to be able to evolve classes in a graceful manner without having to shut down and restart the cluster and reload the data. Right? So, the typical situations that I see in the real world with Coherence applications, that applications evolve somewhat independently. So you can have cluster, and then you have many clients applications possibly using that cluster overextend. And those applications are written and managed by different teams, and they basically need the ability to upgrade one application without having to upgrade all the other applications. They also need to be able to upgrade a cluster without having to upgrade all the applications depending on the cluster at the same time. So if we can do schema evolution the right way, we can basically support multiple client versions, we can support rolling restarts, we can even support with some stuff that G needs to add, we can possibly support hot deploys, right? But the prerequisite for all of that is that we need to evolve schema. So Coherence supported evolution from, first time we did POV back in 2006, POV had a notion of evolution. It had a notion of data version, implementation version, and something called future data remainder. How many of you have used Evolvable in the past? Okay. So those things combined basically allow you to upgrade version of the class in the cluster without having to upgrade the client. And when you move data to the client and put data back in the cluster, you don't lose any of the attributes that you added in the new version, right? Because otherwise, if the client doesn't know about the attributes and only reads from the POV stream and deserialized attributes it knows about, when it writes them back, it will also write what it knows about, and you will lose whatever was added in the new version of the class, right? So Evolvable was designed and introduced in Coherence 3.2, I believe, when we did initial POV implementation, to allow you to migrate your schema forward without having to upgrade everything at the same time and reload the data. So what's wrong with it? Well, for the most part, it works really well if you have flat object hierarchy. If your class extends object, Evolvable works just fine. It works perfect. Right, the problem is that it breaks down with class hierarchies, and reason for that, it's really becomes impossible to evolve anything but the leaf classes in the hierarchy, because if you try to add attributes to anything, to classes at the root of the hierarchy or any intermediate classes, you run into problems, because now you're trying to add something into the middle of the POV stream. It's not going to be read as future data. It's not going to be preserved if you try to marshal class across versions, right? So what do we need to fix it? Well, basically, we need support that will allow us evolution of intermediate classes in the hierarchy, right? So if we want to add attribute to a pet class, we need to be able to do that, right? Because right now, the only thing we can evolve is dog, right? Pet has to stay the way it is. If we want to modify pet, we have to restart the cluster, reload the data. There is no way to preserve any new attributes added to pet, right? So we want to do this. We also want to be able to evolve the hierarchy itself, right? So let's say we want to introduce another class at the top of the hierarchy. That's also not possible now, right? So those are the things that ideally we should be able to do, because those are the things we do to our classes every day. When we refactor applications, when we add new features, we typically add attributes to different classes in the hierarchy without paying too much attention where they are in the hierarchy. We also add new classes to the hierarchy itself. right? So just take a step back. Let's look at the options we have, because we had this problem with how do we serialize class hierarchies all along. And the first solution we came up with, and this was when we actually wrote some of the code that used POF, like extend client, the initial versions of extend clients, and coherence classes that use POF, like extractors, entry processors, anything that's built into coherence. We use this approach because that was the easiest thing to do at the time. So basically what we would do is when we have a hierarchy, child classes in the hierarchy would basically create a gap between themselves and the parents, right? So we would call super read external, super write external first, and then assuming that superclass starts from 0, we would create a gap and basically create our attributes starting at 100. So we can add attributes to the superclass without having to go into our child class and shift everything. Shift index of every single attribute, right? And this works fine if you don't need to evolve data that should be, cluster persistent over time. So for things like entry processors, filters, things that are not really, that are transient in nature, right? This works just fine. You don't really need to worry about evolution because those classes you can redeploy, they're going to be created and used when you need them, and then they're thrown away. They're not really, they're transient in nature. So that was first option. And what this results in, if you look at the POF stream, it's very simple, very easy to parse POF structure that has attribute 0 with the name of the pet, which I'm not showing pet class, but pet class has single attribute name. Well, I did show it in a previous UML diagram, right? And then the second attribute in the POF stream is 100, right? We can skip attributes in the POF stream, and when we are reading it, there is no performance penalty for doing so. But all we are doing is basically leaving the virtual gap here so we can add attributes to the pet class without having to modify our dog class, right? So that was first approach. Then, because of the evolution, one thing that was added in 3.6 is nested POF streams. So you can actually create, instead of having to create a gap, we can create a nested POF stream within a stream and serialize parent class into that nested stream. So now you can do something like this, right? You create nested POF reader at attribute 0, at index 0. So at our index 0, we basically create another POF stream, and then we write the remaining attributes within the stream itself, right? So that was the second step. Unfortunately, this doesn't solve the evolvability problem because, again, the future data, the problem with the evolvable interface as it is right now, it only has a single future data field, single instance of future data, and single data version, right? Which is fine, but which future data and which data version do we use? Do we use future data in the data version from the nested pet or from the dog itself? And the way it works right now, it's from the dog itself. So again, we will get data version for the dog object itself. We will ignore whatever the version is for the pet, and we will read future data. We will read remaining attributes from the dog, and that's the only thing we will preserve across versions. Any classes like pet might have animal as a superclass, so pet will actually have at 0 another nested stream that is basically the serialized animal version. So anything you add to animal or a pet will be lost across versions, right? So this is the third approach, and this is what I'm talking about today. On one of the projects I worked, I started, we had to add support for, they had fairly complex class hierarchies. They needed to be able to evolve them, and they needed to be able to do rolling restarts. So the solution I came up with in the end is based on annotations, but there is a lot more to it. I mean, I just wanted to show you what the end result is, but I'll go and talk about how it works and why it can be as simple as this, the remainder of the talk. So how it works? Well, I created a new interface that is similar to Evolvable interface, but is slightly different, right? I also have a set of, as you see, I have a set of custom annotations because the existing annotations would not give me everything I needed to be able to do. And then I also have two implement. Yes? Okay. Oh. They also have portable type generator and portable type serializer, which work together to create serialization code and to actually use serialization code that was created, right? So let's go through them one by one. Evolvable object, if you're familiar with the current evolvable object, you will see that it's very, very similar. The get data version, set data version, get future data, set future data. This doesn't exist. But the big difference is that now get data version is keyed by type ID. So for every class in the hierarchy, I can keep track of both data version and future data, right? They also have annotations, right? At the class level, I have at portable type. At the field level, you saw one, which was at portable, but there are also annotations like portable set, list, map, array, and portable date. The reason for these annotations, and I can go here and show you some of these. So let's start with the portable type. Portable type basically allows you to define a couple things that we care about. If you look at pov config, what do we define about any portable type? We define type ID. We don't define version. Version is defined using evolvable get implementation version method, right? And we define serializer to use. So this thing allows you to do the same things. Right? Allows you to define type ID, allows you to define version, so you don't have to, because if you saw the evolvable object, it's different from evolvable because it doesn't have get implementation version, which is what you have to implement in a standard evolvable, right? So you define version at the class level using class level annotation, and then if you want to override, by default, the pov serializer to use will be portable type serializer. If you want to write your own for some reason, then you can still override it by specifying serializer class. At the field level, you can define a couple things. You can define since attribute, which basically describes which version of the class this attribute was introduced in, and it is used by the portable type generator to basically implement serialization code properly. Because when you're dealing with class evolution, you really have to, one thing that you have to worry about is how do you read classes back. It's easy to write. When you're writing, you can just append the attributes you want to write in a new version of the class. But you also have to implement your deserialization code, your read external, to check if the stream that you're reading from matches the version of the class that you're trying to read it into, right? Because if you have stream that's version 2 and you're trying to read it in version 3, it's likely that some attributes will be missing. So if you try just to read everything blindly, you will run into EOF exception, because there is no attribute that you care about in a stream. So what you have to do is you basically have to write a piece of code that looks... The what? No, you throw exception. You try to read past the end of the stream, you will get IO exception. It's exception, yeah. You're past the end of the stream. You're past the end of the stream. You're going to get exception. So what typically you have to do is something like this, right? If version is greater than equal, well, don't really need this, right? And the first if you don't really need, but in a general case, that's how you need to read things, right? For each version that is greater than equal than the version attribute is defined in, you read the attribute, right? So in version 2, we added color to the dog. So you have to wrap it with a diff to determine, in order to support streams that are lower version than that, right? So since allows you to define the version of the attribute, right? Order allows you to explicitly define order. There are some rules on how to define how the attributes are ordered in the POF stream by default. By default, they will be ordered by attribute name. If you want to control the order explicitly, you can use order attribute and the annotation to do that. And then you can also specify two things that are interesting when you get to collections, which is basically a class. Which class this object should be. Because if you have a field that's typed as list using an interface and you want to make sure you get back an array list, which is something that out of the box we probably didn't handle in the ideal way when we initially implemented, because you might get back immutable array list in Java, you might get back, you will get back immutable array list in Java, you will get back object array in .NET, right? So this basically allows you to say, okay, I want this to be array list when you deserialize it, or I want it to be a linked list, right? Same thing for maps. I mean, you basically can provide which instance of the class to create for things that accept template. And you can do that either by specifying class name, or if you have more complex creation requirements and want to create something that doesn't have a default constructor, for example, then you can use a factory and implement your own factory that will create an instance of the class you need. So that's portable. And then the other things really just extend that notion. They have all the same attributes, right? And they change the defaults for certain things. So for default, if you mark something with @portable set, the default class will be hash set, and for list it will be an array list, and for maps it will be a hash map, because those are kind of the defaults we use every day, right? So I figure it might make sense to make them explicit defaults, right? What you can also do for any of these collection classes is, for example, for set or array, you can specify element class, and for list as well. And for maps, you can actually specify key class and value class, right? The reason for this is that I wanted to support both uniform and non-uniform collections, right? In order to preserve space, uniform collections are preferred whenever you can use them, right? So if you want serializer to use uniform collections, you basically say, okay, I want uniform list of strings, and you say my element class is string.class, and serializer will use will encode that collection as uniform collection. On the other hand, if you don't, then you just omit it, and by default, if it's not specified, then it will just, each value will have its type encoded. So the question that some of you probably have, why not just use whatever generic type we have defined for collection? And the problem is, whatever is defined in the collection might not actually allow us to do uniform encoding. Let's say we have, going back to the animal example, I might have a list of animals, but the animal within the list might be dog, cat, pig, anything, right? So in that case, you don't really want to use uniform encoding. And if I just assume that just because something is defined as a generic collection, it should be encoded uniformly, it wouldn't work, because I would say, okay, this is animal type, and when deserializing, I would try to create an instance of an animal, which might be abstract, right? So you definitely wouldn't get, even if it's not abstract, you definitely wouldn't get back what you expect. Sorry?
So this information you might be able to infer that we're going to have an element type. So if it's a final type, then it's not a subclass.
Yeah, but I might, my dog might, if I have a list of cows, cow might not be final, but I know everything is a cow, right? It's not. I mean,
the problem is if you have a null in the collection, that breaks uniform.
If you have a null, that makes it what? I don't think it should. If you encode it as a uniform, I don't think it should. Then it's a bug that we need to fix, right? I mean, it shouldn't. So in any case, that's the idea behind allowing you to specify element class, key class, value class. If you want uniform, you specify them. If you don't care, then you don't have to, right? And then the last one is really a date. Where is my? Date, unfortunately, dates in Java are just horrible, right? So POF code that deals with dates is kind of horrible as well. And there are many different ways to represent dates. You can do date as either date, time, or date and time. You can encode it with time zone or without time zone information. So what portable date annotation allows you to do is kind of define what you want. So you can define date mode. By default is going to be date time. And whether to include time zone. By default, time zone is not going to be included. So if you look at date mode enumeration, it's date time or date and time. Right. So those are the annotations. And if just to give you an idea how it would look, for simple attributes, you just have @portable. For primitive arrays, all you need is @portable as well, because they're natively encoded by POF. They're methods that read and write primitive arrays. And same thing for other natively supported object types like string, big integer, big decimal, binary, object, which is just any object, and then enums. All of those things are natively supported, right? For dates, you can use portable date annotation, specifying different modes, specifying whether to include time zone or not. For arrays, you can specify element class and do it as uniform array, or not specify it and do it as a non-uniform. For collections, same thing. Portable set, you can specify factory, you can specify element class, portable list, portable map, right? So those are the annotations. The next piece of the whole solution is portable type generator. Portable type generator is basically a class that does bytecode instrumentation of a class annotated with portable type annotations. And what it does, it basically creates a couple things. It creates the equivalence of read-write external using appropriate versioning logic where necessary. I say the equivalence, it doesn't really implement portable object. The class does not implement portable object interface. The class does not get public read external, write external methods. At the moment, it gets private methods because every single class in a hierarchy is only responsible for serializing its own attributes. I'll get to that in a second. So right now, in order to avoid issues with polymorphism, if I just implement interface and I have public method that's called the same, I'm just going to be calling the one in the leaf class, right? I need to be able to call one at each level in the hierarchy, right? So at the moment, each class implements private read external, write external method with the exact same signature, except for the visibility, right? What we'll probably change it to, based on Gene's recommendation from yesterday, is to make it a public so I can actually call it, because the serializer actually calls it using reflection. And in order to do that, if you're in a secure environment and you don't allow me to set accessible to true, I will not be able to do it, right? So what I'll probably do is just change the code to generate and use methods such as write external $dog, write external $pet. So that way, it will basically be a bunch of different public methods that are generated in the class that I can call easily from the serializer and doesn't require any. It will work in a secure environment as well. It also generates. One of the things that always was kind of weird about POF, you have to create these default constructors. Well, it wasn't weird. A lot of things require default constructors, but I figured if I'm already instrumenting the class, might as well create that default constructor if it's not already there, right? So if you have default constructor, I will not do anything. If you don't have default constructor, I will create one so we can create an instance of a class when deserializing. There was I had a solution initially that didn't require default constructor at all. It would just do some JDK black magic to create class without constructor, but that turned out to be significantly, I'm talking orders of magnitude slower than just having default constructor and doing new instance on a class. So I kind of scrapped it out and threw it away and decided, just implement default constructor if it's not there. Sorry, I can't hear you.
What is the class which you are instrumenting? The serializer type, or you are just augmenting the portable?
I'm changing. No, I'm changing the class itself. I'm just adding methods to the class, not creating another class. The reason for that is I want to be able to access private fields of the class, right? So I don't impose any visibility rules on what your feeds, yeah.
Does that work in IDEA? Does that work in IDEA?
Yeah.
I think Lombok does the same thing and it is working there.
What is not working?
Lombok, it's some similar thing which generates things like get set, things like that.
Right. I mean, it depends how you generate, right? I'll get into, you can instrument class at several different places. I mean, for the most part, you don't care what wouldn't work in IDEA, right? These methods are only used during serialization, right? If you're doing tests, you can either instrument classes at build time, or I have a class loader for my own test. I have a class loader that instruments class at load time, or you can configure this thing as a JVM agent, and it will instrument classes at load time, right? So there are different options on when to instrument. The problem with instrumentation becomes when you're creating things that people actually depend on and need to call from their own source code, right? Things that are kind of infrastructure doesn't really matter, right? Your class just becomes much cleaner, right? So in the future, one thing I'm considering is to also generate equals that is consistent with serialization, because that's one of the problems that we kind of run into from time to time. People implement equals, which is not, for their key classes, they implement equals that is not consistent with serialized form, and they run into issues, right? Because Coherence uses binary versions of the keys to do comparison. So it's relatively straightforward to generate all these methods. Just never got to it. So for how many of you it would be interesting to have those generated automatically and not have to code them yourself? Nobody? Okay. Then I have less work to do. Huh? That's fine. I don't. I mean, I might still do it for myself, but.
Look, one thing I like about your approach is that you have one reflection. Right? Like you look at the global property organization, which is one. You have the cost of reflection for everything. Everything's you generated one thing, one forward. Yeah.
Just once the serialization, I just don't want to write serialization code by hand. I don't want to force people to write it by hand, especially if I require weird naming conventions for the methods, or making methods private, and not having interface and stuff like that. Yes.
Do you have anything for setting default values for? Say you've got a version 1 object.
Right.
You're a version 2 guy. Default values.
There is this thing called default constructor.
Okay. Yeah.
Yeah, I mean, you set default value either when you initialize the field to the default value, or you set it in either directly or in a constructor. I mean, that's how you set default values, right? Yeah. So I try not to do things that are already supported by language so. And at the moment, as I said, portable type generator can be run as from a command line or as JVM agent. I also have, it's just not committed yet. I have a Maven plugin. I need to write an AND plugin so you can actually do this at build time and instrument your classes and just have instrumented classes without having to configure JVM agents. And then the last piece of the puzzle is really a portable type serializer, which effectively replaces the portable object serializer that is used for all the classes that implement portable object interface. And what it does essentially is when you give me an instance of a dog, I look at the dog and say, okay, this is class dog, but superclass. Does superclass have portable type annotation as well? Yes. Does superclass animal have portable type annotation as well? Yes. So I find out all the classes, all the types in the hierarchy that are portable types, right? I figure out the versions, their versions, and I write those versions actually as a zero attribute in a POV stream, because I need those things when I'm deserializing things. I need to know what the indexes for these things are going to be, and what the indexes for these things are going to be are basically their type IDs. So this thing is actually the list of attributes here is sorted list of type IDs for each individual type, right? Because POV has constrained that all the within the stream, all the indexes all the attribute indexes have to be sorted, right? You cannot go 5 and then back to 2 and etc. So you have to read them in sequence. You can skip them, but they have to be increasing, right? So if I create dog and a dog has type ID 1, and then I add pet as a superclass in version 2 and it has type ID 2, then this will actually be reversed. I mean, I will serialize dog attributes in the first stream and pet attributes here, which doesn't really matter because when I'm deserializing this, I will deserialize, call read external method in each one to deserialize its own attributes, right? So this is kind of the stream. If you remember, here we had a very simple flat stream, right? Which is, this stream is great if you want to do things like POF extractors because it makes it very easy. You know what the index of every single attribute is, right? You just have a single integer to find an attribute within the stream. When you go to this, it becomes a little bit trickier because if the attribute is from the superclass, your index for the POF navigator or POF extractor all of a sudden becomes 0, attribute index, right? For some attributes, and then becomes just 1, right? For the other attributes encoded directly in the stream. So when we get to this, we kind of have the same problem, right? Except the problem is even worse now because in the initial implementation, when you use nested streams directly, you actually know what attribute indexes are. With this, you don't. You have no idea what integer each attribute is assigned to, right? So in order to make POF extractors possible, I basically had to write some utility code. I know which index is assigned to each attribute, right? So I had to write some utilities that allow you to get POF navigator, POF extractor, and POF updater. And while I was there, because I knew about attribute names as well, I figured I might as well do this. Right, so you don't have to ask by index because you don't know index, you're not expected to know index, but you can basically say, give me extractor for attribute with this name. Or in this case, give me effectively a chained extractor for POF, for nested POF objects, right? How many of you have tried to use chained extractor with POF extractor? Did it work?
Yeah.
Huh?
No. It was a pain to try and lift them up.
Well, it's actually supported out of the box. It's just not supported with chain extractor, right? The problem with chain extractor, if you think about it, chain extractor calls the first extractor in a chain. The result becomes the target object for the second extractor, etc., right? The problem is POF extractor expects to work on a binary. First POF extractor, when it extracts something, it gives you an object, deserialized object, right? So the second POF extractor doesn't work. Now, what does work is you always have the ability to pass POF navigator to the POF extractor, which effectively eliminates the need for chain extractor. So you can say if you have address object and then nested city object, or city attribute in an address, and address is nested in a person, you can basically say, okay, address is 1, so you can say, and city is attribute 2 in an address. So you can basically say new POF extractor, simple POF pet 1, 2, right? And that will work. That's basically how you chain using POFs. But you had to keep track of those attributes yourself. Now, because I know how each attribute maps to the index within any given class, I can allow you to do something like this. And we can take this step further and make it actually type safe and whatnot. I mean, there are many different options. There are a lot of things that we're actually talking about building on top of this infrastructure and actually doing something that we talked about from the very beginning and wanted to do from the very beginning, provide you a schema, right? Provide the meta model for your POF types so you can actually get things easy. Extractors, attributes, whatever, right? Get them easy from the POF stream in a type-safe manner without having to worry about integer indexes of the attributes. All right, so that's pretty much all I have. So I'll open it for questions. Yes.
It's slightly unrelated. Brian probably talked about 2 years ago dealing with the POF namespace. Anything to be done with that?
Gene?
I'm sorry.
POF ID fashion. So here's reserved for 1,000. If you're talking about running that's fashion of type rate. Brian talked about something 2 years ago.
Well, not really. You can understand that you need some kind of registry, but what you can try to do is what that's just wrong. Right? You need the DNS.
Yeah.
The DNS.
Okay, so but even with like Android, with Android,
Well, it's an organization.
they could have I think what we really need, to solve issues with operating types and whatnot, we need to make things more modular. You don't need one pop config, you don't need that. You need to be able to create components that have their own pop configs that are fully self-contained. They talk to other components by interface with your fine. Right? In that case, you can encapsulate each component can encapsulate its own pop configuration. The types can be the same. It doesn't matter. There will be different caches or not.
So using the new car.
Yeah. So that is the first step. I mean, there's more work that needs to be done, but I think in the long run that's probably the best option instead of trying to come up with namespaces.
So like, yeah, it's stuff like SGI.
Yeah. So.
So before. Actually,
There was still by that. There was still about big emphasis on an ID model.
Okay, before we get into this, I just wanted to show you. I forgot to show you that it actually works, right? So, I mean, it's all. I mean, I know you believe me, but right. So I have. This is my first version of the pet, right? It has a single name attribute. My dog has a single breed attribute, right? So I basically have two attributes in the stream, breed and name. In version 2, I'm doing a couple things. I'm adding animal with a species to the root of the hierarchy. Dog gets additional color attribute. And pet gets additional age attribute. So I'm adding new class to the top of the hierarchy. I'm adding attribute at each of the other two classes, right? And this is the test. This is the test that I have a bunch of them, but the one I care about is the one that tests evolution, right? So what this does, I mean, it uses a couple different POV contexts, one POV context per version, right? So I create an instance of the dog version 2 that has all the attributes in it. Name, age, breed, and color. Right? It will actually set species internally within the constructor. Print it out, right? So then I convert it to binary. So this is binary version 2. This is version 2 of the data. Then I use context version 1 to deserialize this and get dog version 1 and print it out. But then I take dog version 1, serialize it back using the same context, deserialize it back into whatever object it is using context version 2, and make sure that dog 2 and the one that was round trip to 1 and back are actually the same. Right, so I'll talk about it. Yeah. Oh God, let's run the whole test. Of course he doesn't. This is the first time I tried to run a single method. Yeah, because it didn't, for whatever reason, it did not instrument them when I just ran it as a method. So now when it did instrument them, you can see that test evolution actually passed. No, you don't. You don't. Because, yeah, you can use standard types, you can use, anything that you annotate with that portable type and provide annotations, I will instrument within your POF config. You basically have to specify portable type serializer as your serializer, right? Or if you want to use it for everything, you can set it as a default serializer, right? So, but you can always, it's just another POF serializer, right? So you can mix it, and you can do your enum POF serializer for enums. You can do, even though well, yeah, you would have to do enum POF serializer for enums. You do portable type serializer for anything you annotate with that portable type. You do just default portable object serializer for things that are portable objects, and you can do your own serializers for other things, right? So you can mix and match. It's really just, as I said, it's to a certain extent replacement for portable object, because I think it gives you more flexibility. It is slightly faster. This is not the right test. I mean, this is significantly faster for whatever reason. It's significantly slower here. It's about 2.5 times slower than the portable object serializer, because it has additional work to do with to keep track of different versions and future data and whatnot, and to actually to invoke those methods over reflection. So it is slightly slower. It's still significantly faster than standard Java serialization, and what you end up with is POF stream that's just as compact as if created any other way, right? So you don't lose anything from the POF perspective. You just lose a little bit on performance during serialization to serialization, right? Yeah, you get full versioning for classes across the hierarchy, right? So where you can get it, there is I moved everything. I used to have this. This is the project I started when I was working on the book. It was in Google Code for a long time. It has a lot of stuff in it, not just it, but this. But there is, if you go there, oh, I don't have internet here. If you go there, you will see POF as one of the sub-modules of the project. All of the stuff I talked about is already there. It's available. You can take it. You can play with it. Send me feedback. If you have any questions, shoot me an email. So it's already there. I mean, I'm hoping to roll it into the product in the future. Yes, if we roll it into the product, it will have to be supported across the board, right? So we have to figure out. I mean, .NET we can probably do, although it is a little bit trickier than Java because of the way assemblies are. You can do bytecode generation, but yeah, we'll figure it out. C++, I'm really not sure how to do. Somebody else will have to figure that one out. So. Could. I do generate source code for something else. There is another, within that same POF module, there is another generator for, which at the moment, because it was written before I had this, at the moment it generates portable objects. It's basically an XJC plugin which takes XML schema and just, when it generates your Java classes, when you run your XML with XSDs through XJC to generate Java class, it will actually it will implement portable object and create read external, write external methods, right? So yeah, I mean, generating source code would be an option. It's something we can. This was, at the moment, it was easier for me. It seemed like a better idea. Well, actually, yeah, I know why not source code, because I would have to modify your source code, right? This way, I take the class and I do what?
Yeah, but this having the only reason why you modify source code is to generate stuff in the class itself.
Right.
And
so generating separate classes, yeah, then we have problem with this.
Yeah, just to try it's such a big cost to not be able to have it visible.
Am I the one who can impose a requirement on it, right? I don't want to do
You have to type this if as best.
the what?
You have to type if as best.
Yeah, you have the time.
It's not ours to decide.
Yeah, it's not my fault, right?
In the case of
Yeah,
But
But I definitely, one thing I don't want to do is modify the existing source code or try to add anything to it.
Still the other question is
Because we're running a conversation over lunch.
Sure.
Thanks so much, Alex.
Thank you.
Yeah.
Oh, I forgot to click.
Yeah.